All right, let's see what you remember from yesterday. We got a boat question here. See if we can do it. Okay, guys, so we'll just draw the diagram here. I'm not going to do the whole thing because you're probably still working on it. Okay, so what we know is that the river's 200 meters wide. Okay, and we know that's supposed to be 200. Okay, and we know that the person is rowing at 3.5 meters per second. Okay, and it says person rows a boat directly across a 200 meter wide river. So the rowing looks like this. Is this a rowing across or going across question? It's a rowing across question. I mean, it outright says the person is rowing directly across. It doesn't say they're going directly across. It doesn't say anything about ending up straight across. In fact, it goes as far as to ask you how far downstream they will be. That means they're definitely not going across. Okay, so we can kind of take all of those contextual clues, okay, from reading the question. So this is 3.5 meters per second. And this is going to be 1.2. Okay, and that's east. They actually do give us compass directions here. And then our resultant will be that right there. Okay, give you a few more minutes on that one, guys. So the first thing it wants is the resultant velocity, so that's the green line. And to get that, we're just going to use Pythagorean theorem. Right, we have the other two sides of the triangle, so 3.5 squared okay, plus 1.2 squared. And then to get the angle, it doesn't ask for a particular angle, so we can just find this one within the triangle. That'll be east of north. Right, so theta will equal tan to the minus 1 of the opposite side, 1.2 over the adjacent side, 3.5. Okay, and we'll get that as soon as my calculator fires up. Okay, taking a long time last few days. And then they also want to know how far downstream they will be when they reach the other side. So downstream is actually this direction. So I need to know what this displacement is here. In order to do that, what do I need to know?
Time.
I need to know time. I need to know how long they're rowing across the river. Because as long as they're rowing across, they're also floating downstream. So if I can find that, and I have enough information to find that, okay, I can find time with the across information. T will equal d over v. It's 200 meters across, divided by 3.5 seconds. Oh man, it's taking forever to fire up. Okay, once we have that time, then we'll use it here. Okay, sorry guys, I'm just trying to kill time while my computer figures out what it's doing with that calculator. Okay, once I have that time, then I can use it here and go d equals v times t for the downstream part. So that time is shared by both across and down the river. All right, so it just won't be on the screen here, guys, because I don't know what's going on with that. So we got square root of 3.5 squared plus 1.2 squared. So that's going to be 3.7 meters per second. And the angle is going to be second tan of 1.2 divided by 3.5, which is going to give us 19 degrees east of north. Okay, so our final answer for that would be 3.7 meters per second at 19 degrees east of north. Okay, you may have also had 71 degrees north of east. As long as you have the right compass combination on there, you're fine with that one. And then, in order to calculate the time, so that's the red calculation here, okay, we're going to take 200 and divide by 3.5. All right, it's going to take 57.14 with a bunch of other decimals seconds to get across. that number carries over to here because while we're going across, we're also going downstream. Okay, so that calculation will simply be 1.2 times the 57.14. Okay, so 69 meters downstream. Okay, everybody all right with that? Ringing a bell from yesterday? All right, so that's a typical rowing across question. Try this one. Okay, guys, just to get the diagram done here. Okay, there's the river, it's 50 meters wide. Okay, flows at 1.8 meters per second east, and we know that they want to end up going straight across. So that's my resultant. Okay, the river current will look like this. Okay, 2.5 meters, sorry, 1.8 meters per second. Try that again. Okay, and then we'll have our rowing speed, which is 2.5 meters per second. Okay, so it should look something like that. It's a, what kind of question? Going across, yeah, because it says specifically they want to end up straight across. It's a going across question. You are simply looking for the heading and the amount of time it takes to cross. Okay, so first thing we got to find is the heading. Simple enough. We have the hypothesis, the hypotenuse and the opposite side. Okay, so to find theta will simply be the inverse sine of the opposite side, 1.8 divided by the hypotenuse, 2.5. Okay, so inverse sine of 1.8 divided by 2.5. Whoop, put it in brackets, and I multiplied, which it doesn't know how to do. 1.8 divided by 2.5. Okay, so, oh man, the struggle is real. 1.8. Third time's the charm. Okay, 46 degrees, and that'll be west of north. Okay, as the direction that we need to head on that one. All right, in order to figure out how long it will take to get across, I know it's 50 meters across. What I don't have is how fast we are crossing. So I do have to find that. It is the resultant here. Okay. Since I've now calculated this angle, I could use cosine to get the adjacent side, or I could go c squared minus b squared equals a squared. It doesn't matter which way you do it. Okay. I prefer the trigonometric way, so I'm just going to go cos of 46 degrees times 2.5, so cos of 46, cos of theta times hypotenuse to give me that adjacent side. All right, so that side's going to be 1.7 meters per second. All right, and then from there, now that I know the distance and the speed, I can calculate how long it takes to get across. T equals d over v, so that's going to be 50 over 1.7. And we're looking at 29, because we only have two significant digits, so 29 seconds. Okay, ringing a bell from yesterday? All right, I would bet that you could see one or the other of those, but not both, on your unit exam. You're either going to have a rowing across or a going across, but there's definitely going to be a boat question. All right, plan for today, guys, we're going to do a few different examples here of the vector component stuff, finding all the x's and y's and all that. Then tomorrow, just to break things up, we're going to do a little group activity with mapping, A, B equals D over T mapping. So it's some vector stuff, but it's not sitting there doing problems on the worksheet all day, okay? Because I get it, that gets pretty dry pretty quickly, okay? Remember, this Friday's quiz is going to be on vector addition, and the practice quizzes that are appropriate are 7, 8, and 9. So if you want to have a look at those and watch the solutions video, you can find all of that in Google Classroom. Okay, not a bad idea to do that. All right, I would like you guys to try that one. See how we do there. Scale is going to be important on your diagram here. So you can compare your diagram here. Okay, we got 620 kilometers an hour, 40 degrees west of south. Okay, so I'm going to draw my due south line here. Okay, then I'm going to go 40 degrees west of that. And then we got to put on a 500 kilometer an hour, so a shorter line, 75 degrees east of north. Okay, so there's my north line. Okay, 75 degrees is going to be like way this way. Okay, east of north. Yeah. Okay. Yeah, probably something like that. Maybe a tad longer, but I'm going to leave it like that. Okay, so this is going to be the triangle for that one. This will be 500 kilometers per hour. Okay, and that angle there is 75 degrees, so X and Y, and then Y and X. And then my resultant should go like that. Okay, I think it should look something like that. And you can clearly see why scale is so important on that one. Okay, if you don't end up in the right place, you could get the wrong vector. You could have it being west of south or something like that when it's not. So first thing we got to do, now that we've got the diagram drawn, which as we said, is about as tricky as you're ever going to get, right? This one is so close to, does it get past where I started or not? Like scale's super important, okay? Now we got to calculate all the X's and Y's. So let's start out with the first triangle here that's black in color, okay? And we are going to look for X first. X is the opposite side, so we'll go sine of 40 degrees times 620, okay, to get us our velocity vector pointed west. Right, so we'll go sine of 40 times 620. So that side's going to be 398.53 kilometers per hour west. Right, to find the Y, it's adjacent to the 40-degree angle, so cos of 40 times 620. All right, so that side is going to be 474.95 kilometers per hour, and that one is directed south. For our green triangle that goes north and east, okay, the X component is again the opposite side, so I'm going to go sine of 75 times 500 kilometers per hour this time. Okay, so that ends up being 482.96 kilometers per hour east. Okay, so definitely bigger than the west component. I probably could have drawn it a little more that way. Okay, and then the Y component is the adjacent side, so the cos of 75 times 500. Okay, so that side's going to be 129.41 kilometers per hour, and that is going to be north. Okay, now just so you know, if this is a question on a quiz or something like that, you'd get a mark for your diagram. Okay, you'd get a mark for calculating any x or y components that require a calculation. Okay, you'd get a mark for calculating your resultants x and y. You'd get a mark for your Pythagorean theorem. You'd get a mark for your vector, and you'd get a mark for your final answer. Okay, this one's got additional steps after that. It could be up to 10 marks. Okay, it's a lot of work, so you deserve a mark for every step. So, show your work. Okay, because if all you show me is an answer and it's wrong, I have to give you nothing. And that's bad when it's out of 10 marks. Okay, so show all your work in case you just make a calculator error somewhere. I can still give you some part marks along the way. Because that happens. There's a lot of calculating here. Doesn't mean you didn't know how to do it. It just means you're not good at punching numbers into your calculator. Okay, which is not nearly as bad. Right. So now we got to calculate our resultants x and y. So our resultants x is going to be 398.53 kilometers per hour west, plus our 482.96 kilometers per hour east. So basically I'll be subtracting those two in order to get my total x here. So I'll take that 482 and I'll subtract the 398. So my resultant x is 84.43 kilometers per hour east. Okay, and then for y, I'll have the south and the north. The south is obviously way bigger, so we'll go to 474.95 minus the 129.41. All right, so my overall y is 345.54 kilometers per hour, and that is south. Okay, so now that I've got all those, now I can find the resultants, okay, which is my average velocity over the whole trip, okay, by simply doing Pythagorean theorem with those two numbers. So the 84 squared plus the 345 squared with all the decimals, obviously. Okay, so all right, so we're looking at 355.70 kilometers per hour. Okay, then we need the vector, the way I've drawn this triangle, and you could have easily drawn it the other way and gotten east of south, totally fine. Okay, the way I drew it, I've got x as the adjacent side, y as the opposite, so tan to the minus 1 of the 345 over 84. All right, so we're looking at 76 degrees. And for me, that is south of east. All right, now, that's the first part. What's the average velocity of the plane? Okay, what's the overall velocity? So to two significant digits, since that's all we have, this would be 3.6 times 10 to the 2 kilometers per hour at 76 degrees south of east. The second part of this says the plane flew for 7.5 hours. What's the displacement? Well, I don't have to do anything with the vectors anymore. I already know which direction it's flying. That's the direction it will be displaced. Okay? But I do need to calculate what d is using v, which I spent all that time calculating, times t. All right, so all I have to do is take that number I spent all that time calculating, that one right there, and multiplying it by 7.5 hours, and I should get 2.7 times 10 to the 3, again, at the same vector. So meters at 76 degrees south of east. All right, is that a really long, super involved question? I will never give you one like that on a unit exam. It takes too long. All right. On a unit exam, I would give you one that takes a lot less time, but still shows me you know how to do all the parts of this. Okay, so on a unit exam, expect that you would probably get like one that's vertical and one that's angled, or one that's horizontal and one that's angled, right? It takes less time, but you still have to demonstrate to me you know how to do all the parts. But a question like that one takes you about a third as long as the one you just did. Okay, everybody with me there? All right, now I'm going to show you a video of someone who has no understanding of vectors. Okay, it may destroy your faith in humanity, right? But it'll also give you a little chuckle. Okay guys, I'm just going to do the diagram up here. Okay, it's a messy, busy diagram, but something like that. Okay. I think the trickiest one to draw is the last one. Okay, the 18 meters at 40 degrees east of north. Okay, that's probably the trickiest one. I think in the end, my diagram's a little bit off, but it's generally in the right direction. Okay, I think this angle ended up being a little bit big. I probably could have made this line a little bit shorter, okay, and it would have worked out a little better. But when you've got 5 vectors in there, it starts to get kind of crazy. Okay. Okay guys, I'm gonna start working through this one just so I actually finish it, because it's gonna take a little while. There's a lot of calculating. All right, so starting with the red triangle. Okay, we've got to find x. X is the opposite side, so that'll be the sine of 30 times 25, which is 12.5 meters west. Okay, y is going to be the cos of 30 times 25. That one I can't do in my head. Cos of 30 times 25. That side's going to be 21.65 meters, and that is north. Right, for our green triangle, okay, we're going west and south, right? So for our x, it's the adjacent side, so cos of 18 times 46. Whoops. Cos of 18 times 46. Okay, is 43.75 meters, and that is west. And then for our y, it's the opposite side, so sine of 18 times 46. All right, so that side's going to be 14.21 meters south. And then we already have blue x and blue y because it's due south, so x is 0 and y is 10 meters south, okay, just because it goes straight and it has no triangle. And then we have the purple triangle, which is got a 40-degree angle. X is the opposite side, so the sine of 40 times 18. Sine 40 times 18, all right, is 11.57 meters. That one's east. Okay, and then for y, it's the adjacent side, cos of 40 times 18. That one's going to be north. Okay, so that side's 13.79 meters, and that is north. Okay, now we finally got all the x's and all the y's. Now we can find our resultants, x and y. Okay, in other words, how far west and how far north Indiana Jones actually runs over the course of the opening scene of the movie. Okay, so I've got to take all the x's in order to get black x. All right, so I'm going to have positive 12.5, positive 43.75, plus 0, plus negative 11.57. All right, so those are the ones I've got to put together. All right, so I need the 20. All right, move this over. Sorry, the 12.5, because I didn't actually punch that one into the calculator. So 43, I need that one, plus 12.5, plus 0, plus, or minus, sorry, the 11.57, plus minus. That's not going to work out well when I press enter. All right, so our total x is going to be 44.68 meters west. Okay, and then for our y's, one of them is north, sorry, two of them are north, two of them are south. Okay, so we're going to take the 21.65, that one there, that one's north, plus, or actually minus our next one, which is south, the 14.21. And minus 10, because it's due south. And then add on the north one, which is 13.79. This one. Okay, so we end up 11.22 meters north. Those agree with my diagram. X is considerably longer than Y. Okay, we got north and west there, so we're good. Now I can calculate what D is. D is just going to be Pythagorean theorem of those two sides. So second of that one squared plus that one squared is going to give me 46.1 meters. Okay, I'll need theta. Okay, theta is going to be for me y over x. So inverse tan of the 13.79. No, sorry, the 11.22. Divided by the 44.68. Okay, so we're looking at 14.1 degrees. And for me, that is north of west. Okay, in this question, we have, well, at least for part A, 3 significant digits. Everything I was given had 3 significant digits. But in part B, the 2.5 minutes only has 2 significant digits. So when I'm calculating part B, all I'm doing is going D over T. Okay, but I should change the minutes to what? I should change them to seconds. Yeah, I was given meters. Okay, so I should change that to meters per second, rather than getting meters per minute. Okay, so 2.5 times 60. Okay, there we go. We'll take our displacement, divide it by the time, 150 seconds. All right, and we get 0.31 meters per second, and that should just be at 14 degrees, not 14.1, 14 degrees north of west, okay, for that one. And then what's his speed? Well, how do we get that? That's a weird question. We haven't had that. Speed isn't vector, is it? Speed is scalar. So all I do to get speed is I go 25 plus 46 plus 10 plus 18 and divide it by 150 seconds, right? It just cares how far he goes. That's the distance, okay? Once in a while you get a little trick like that. Okay, tomorrow. You're going to be working in a group on a map activity. You'll have tomorrow and Monday, probably most of Monday, to work on that. Friday, obviously, is your quiz. Okay, so if you need some help with any of this, please pop in and see me.